solving equations by adding or subtracting. And our first I can statement says, actually it's our only I can statement, I can manipulate and solve equations by adding and subtracting. I use the word manipulate because you can change this equation however you like, so long as you do the same thing to both sides. Let's start off with our first definition. The addition property of equality says something very simple. Okay? If you add the same number to each side of an equation, then the two sides remain equal. Well, I think all of you would agree that this makes sense. If you have an equation, you have to have an equal sign and you have to have two sides to that equation, something on either side. There could be 0 here, but at least it's still a side of the equation. That equal sign means that whatever's on the left must equal whatever's on the right. And I think you would all also agree that if I just added 4 to this side, and actually, if I just added 4 to the first side, the left side, that side is now 14. That's not equal to 10. So in order to keep the two sides equal to each other, you've got to add 4 to that side as well. So in order to keep this equation true, if you want to manipulate it in certain ways, you must do the same thing on the left side. You must do the same thing on the right side that you do on the left side. You have to do the same thing to both sides so that your equation remains true. Alright, so for example, you have x minus 3 equals 7. If I are asked to solve for x or get x by itself, since I'm allowed, according to my addition property of equality, to add the same thing to both sides and still have a true statement, a true equation, I'm going to decide to add 3 to both sides of my equation. So now, on the left side, I should have x minus 3 plus 3. And on the right side, I should have 7 plus 3. And what you're seeing here is, oh, well, this is kind of silly, Mr. Dudek. Minus 3 plus 3, those things should cancel out and make 0. Well, I did that on purpose, guys. If I'm asked to solve this equation, to figure out what x is, I'm trying to get rid of this negative 3, okay? Because once I get x by itself, I'll be able to tell that the only possible solution for x that would make our original equation true is x equals 10. In other words, 7 plus 3. Guys, the great thing about working with equations is that you can always check your answer. You should never have to turn in your work to me or to any other math teacher and wonder if you got a question right, an equation right. So how do we check if this is the right answer? Well, you take your answer, x equals 10, take it all the way back to your original equation, and you plug it in for x. So the question is, does 10 minus 3 equal 7? And since it does, you know you've done this correctly. So your answer is good. Okay, guys, over here on the right, just like last night, we have the general case. So it says for any numbers a, b, and c, if a is equal to b, then I can add c to both sides, and you still have the left side, a plus c, equal to the right side. Okay, so it's saying that this works. This works. I can add any number to the left as long as I do it to the right. And over here, keep in mind, I added 3 on purpose because I was trying to cancel out this minus 3 right here. I wanted to get x just by itself. Okay, let's move down to the next part here. The subtraction property of equality, it really says the exact same thing, except we're talking about subtraction. If you subtract the same number from each side of an equation, the two sides remain equal. Okay, so the goal when solving an equation like this right here is to get x by itself. I'm well aware that you guys, ever since you were little, have been doing things like this. Hey, 4 plus blank equals 14. I know you all know immediately that the blank spot, or the x, it's 10. But that's not the point. We're starting very small, and we're going to get more and more complex as the days go by. So we need to understand the basics of solving equations if we're going to be able to solve the tougher ones. So in order to get x completely by itself, we need to eliminate this positive 4 that's also on the left side of the equation. So our subtraction property of equality says, hey, I'm allowed to subtract 4 from the left side of my equation as long as I subtract 4 from the right side. I should still have a true statement as long as I do the same thing on both sides of my equal sign. Okay? And if you remember, just like in the one above, now I should have 4 plus x minus 4 on the left side, and on the right side I should have 14 minus 4. Okay? I'm taking this step by step because we're just getting used to it, but obviously you could have just said, well, 4 minus 4, Mr. Dudek, that's 0. Yeah, once again, I did that on purpose. Positive 4 right here, negative 4 right here. You want those guys to cancel out. You want them to cancel out so that your x is left all alone. So x is going to be equal to 14 minus 4, which is obviously 10. That's the answer we knew right off the get-go. But the point of this example is not that x is equal to 10. The point is that you understand that if you subtract a number from one side and you subtract a number from the other side, you still have a true statement right here, a true equation, okay, because you balanced both sides of it by doing the exact same thing. And by doing the exact same thing, you are able to eliminate and get x, our variable, by itself. And in later days, that's going to become more complex, but it's going to be all the more important that you understand that you can subtract from both sides. Okay, once again, over here you have the same. You have the general case, just like we had right up here. Okay, one more part on this slide. Equivalent expressions. Actually, that should probably say equivalent equations. So maybe you cross that out and write equations underneath. Equivalent equations are equations that have the same solution. So our two examples right here, even though they don't look the same, okay, and we didn't use the same steps to solve them, we added 3 up here, we subtracted 4 down here. We call them equivalent equations because the solution to both of them was 10. Okay? So basically we're saying their answer is the same. That's a piece of terminology you need to try and remember. Alright, let's move on to example 1. It says solve x plus 4 equals negative 3 and graph your solution on a number line. Once again, I'm well aware that you could probably tell me right off the bat what x is, but we want to get in the practice of solving equations properly. So we're going to do it this way. How can I get x by itself? Well, I obviously want to eliminate this positive 4 that's also on the left side. In order to get this positive 4 down to 0, I'm going to do the opposite of add 4, and I'm going to subtract 4 from the left side of the equation. But in order to maintain a true statement here, I've got to do the same thing on the right side. So there's that. What do I have left over? Well, my 4 and my negative 4 cancel out, and I just have x. And then I should have negative 3 minus 4. I'm writing that out so you can all see what it should look like. So when you simplify that, negative 3 minus 4 is negative 7. So that's our answer. Oh, but wait, let's make sure that's correct. Let's take it back to the original equation, because you should always check yourself since you can, and say negative 7 plus 4 better equal negative 3. Well, guess what? It does. So it checks. That's our safety valve. We can always check that. Now, x equals negative 7. It says to graph our solution on a number line. Since the only number that can make this statement, this original statement true, x plus 4 equals negative 3, the only thing that can make that true is if x is negative 7. That is our only answer. There's only one solution to this. So we just fill in a dot, a circle. Hopefully hopefully a nicer circle than that, on negative 7. And that is how you graph your solution on the number line. Alright, let's do one more basic example solving an equation. It says solve y minus 3 equals negative 14. When it says solve an equation like this, basically it's saying, hey, get y by itself. I want to know what y should be so that this makes a true statement. Okay? So in order to do that, the easiest way to do that is to say, alright, I've got y minus 3 here. So let's do the opposite of subtracting 3 from y. That was a mistake. Okay? And let's add 3 to both sides. So here you go. What do you have left? Well, y minus 3 plus 3 is really just y plus 0, or y. And negative 14 plus 3 is really just negative 11. So y equals negative 11. Hopefully by now you know how to check that. You're going to take it all the way back to your original, and you're going to say negative 11 minus 3 equals negative 14. And hopefully you can tell, since you know how to add and subtract integers, that that does check. So that means you have the right answer, the only answer that makes this equation true. Y is negative 11. Alright, let's go to our last question here, number 3. Write and solve an equation to find the height of Guadalupe Peak, the highest point in Texas. Driscoll Mountain, with a height of 535 feet, is the highest point in the neighboring state of Louisiana. It is 8,214 feet lower than Guadalupe Peak. Alright, so we also need to get in the habit of using equations, of writing equations to represent situations. In order to write an equation, you must have a variable and you must have an equal sign like we have up here. Otherwise, it's not an equation, it's just an expression. So, first let's ask ourselves, what are we looking for? It says write and solve an equation. Okay, so we're obviously going to have to write an equation. And it says to find the height of Guadalupe Peak. That means we don't know the height of Guadalupe Peak. Anytime you're looking for something, you have an unknown number. That is always going to be represented using a variable. I don't care what letter you use for your variable. I'm going to use x. But that is what you're going to name your variable. I'm saying, let's let x equal the height of Guadalupe Peak, since we don't know the height of Guadalupe Peak. Now, let's use what else we do know to write an equation that we can eventually solve and figure out the height of the peak. So Driscoll Mountain has a height of 535 feet. It is 8,214 feet lower than Guadalupe Peak. That means you could write an equation, the height of Guadalupe Peak minus 8,214. And you can set that equal to, of course, the height of Driscoll Mountain, 535 feet. Okay, so the height of Guadalupe Mountain minus 8,214 feet should equal Driscoll Mountain, because that's what we're being told here. So now the last step, because we're trying to find the height of Guadalupe Peak, is just to solve for x. Okay? So in order to do that, in order to get x by itself, you do the opposite of subtracting 8214, and you add it. But please, please remember, you must do this on both sides of your equation in order to make sure that the statement, the equation, remains true. Okay, you're balancing your equation when you add to both sides the exact same thing. It becomes out of balance if you forget to add to one and you do add to the other. So here we go. 8 minus 8,214 plus 8,214 leaves you with just x. And of course, when you add these two numbers together, you get something like 8,749 feet. Yeah, that's right. we let x represent the height of Guadalupe Peak. So when you write your equation and you solve for x, you're left with the actual height of Guadalupe Peak. So equations can be quite useful. Okay, just a couple reminders. When adding or subtracting in order to isolate a variable, you must, absolutely must, add or subtract the same thing on both sides of your equation. If you don't, your equation is now unbalanced, and you now have a false statement. So you're going to get the wrong answer for your variable. You must keep the equation balanced. And number 2, please always check your answers when you solve an equation. No other class lets you instantly know whether or not you have the correct answer. That's why math's so great. Yeah, it's one of the reasons math is so great. Alright guys, have a great night. We'll see you tomorrow.